Okay, this is the let's wait like 2 more minutes before we start. Okay, someone joins. If you have any question before we start, just like write on the chat or just speak. Well, start sharing the slides. I think I'm going to start because we have like, quite some things to cover today, and the first few slides are a brief of introduction and summary. You will see that the lecture today is a bit different, and maybe like the first part you may be wondering what has this to do with Android, but you will see that it's like very related at the end. So yes, so yes. Last week we were talking mostly, one important part was about location, but I know that we only talk about getting the location once. We didn't have time to cover about location updates. And that's it. To do, you can set like, I want to get the location every 2 seconds, and every 2 seconds I want to receive a callback to get an update of the location. And what we didn't talk about either was about maps, how to integrate a maps in your app so that you can combine with the location and show you have used Google Maps, so it's, you know what it is like including a map view into your app. But I think it's kind of important, but since today the topic is kind of different, I want to just to focus on the topic of today, and next week we will introduce, I think will be lecture and a half about Arduino and how to control an Arduino with the phone using Bluetooth. And then the following 2 lectures, we will go back to just Android, and we will cover more in detail maps and location. And I also think that it's also important, well, it's not that important that we break the topic of maps, because it's, you typically, if you want to get the location often, you would want to do that in the background of your app. So we will talk about background service. A service is a task that is being done in the background. So we will, when we talk about background services, we will also combine it with maps and location, so that we learn about location update using maps and also how to get the location in the background. But today it's I think the first part would be speed up in deep learning. So I know some of you have no experience, so I prepared this lecture for like having 0 experience with deep learning. If some of you are like experienced, the first part may be a summary or a review. And that would be just the first part. And the goal, well, I think this is, we're going to do a class activity. I want to break it into parts. We will do the activity, get back to the lecture, and then the second part. I still have to, I think I can manage how to rearrange the same groups the second time, because I didn't have time to try that. But I think my hope is that we can keep the same groups the second time. And so the idea is we want to develop an Android app that is running a neural network model so that we can recognize handwritten digit. I provide the app for this activity, and the model I provide step-by-step like what you have to do, so it's very straightforward. And the assignment, so this class activity is like, if you do it more or less well, it would be very easy then to do the assignment because you already know how to set up the environment and all of those things, is to develop an Android app to recognize some gestures. And I think I will talk a bit more about the assignment and this later. But before we jump into deep learning and the models in Android, last week someone asked about data binding. It's kind of a more advanced topic because I think this class could have a second part. Like what we are doing this quarter is learning about, like, in general, all you can do with Android, or many things that you can do with Android, and not focus on like doing them well, but being able to implement many different functionalities so that you know what it's capable of doing. And the next would be like part B of this continuous version of this course would be to learn more in depth, like the part of programming and coding. But so this is kind of a bit more advanced, but since someone asked, and I think it's also important, I have prepared some slides. I will talk about V-binding. Data binding, I will briefly talk about it, and I may come back to data binding and maybe explain it a bit more, or someone has questions, because when we talk about recycle view list, it's related to, I have an app, it's related to data binding, so I will come back to data binding in two lectures from now. So they are related, view binding and data binding, but they are not strictly the same thing. So yes, the idea of view binding is to replace the view ID with using a binding object. The advantages is type safe and null safe. So when you define data binding in your app, there are three main functions that you have to implement: inflate and bind, to bind the layout to your activity. The best thing is, because I don't want to spend too much time on this because it's a bit more advanced from what we want to learn in this course, but I have here text for reference. So I'm going to show it by checking the Pictionary app that we did some lecture ago with the view model and add data binding, view binding. Yes, yes. Well, I will do that, and then I will go back to but we can do that quickly. So if you remember, we have this Pictionary app with the draw view, and yes, I think was basically drawing something on the screen and did nothing, just to maybe change some buttons on text views. So to include the data binding, yes, so let me, I think, copy from here. We enable that in our Pictionary. I always forget. In module app, it was here. Enable what is, and I should have prepared this so that, okay. So when we add data binding, I think, I'm not sure if I'm adding it in the, yes, I think it is. When we add data binding, Android is going to create some binding class for this app that, yes, well, I don't want to give too many details. And so now the idea is to replace this find view by ID with using data binding. So first we have to declare our binding object. let's call it binding equals activity main binding. I will explain dot inflate inflator. So this class, this is an under class. I didn't create it, but when I enable the data binding in the Gradle, this class is already being generated for binding your layout to your class. And the name, it's by default the name of your activity, and in all cases, main activity. If you had a different name for the activity, it should be the name that you write here, and then binding. Yes, that your class was activity second would be activity second binding. And let's just replace one so that because the rest is the same. So, and now we can use this binding object to check dot. And well, here, so the idea is that you would not need to declare this, and here you could dot text equals did I change? Was doing this earlier. Oh, I see. Sorry. I see. It's okay. This is just to the variable that I declare here, but you want to refer to the actual ID. Let's see what errors it gives. I'm not sure. Like when I try to do the example live, something always happens. But I think, well, but I think something probably, I will look this during the break because I don't want to spend more time on this, but maybe because I have this imported, I don't think it is, but maybe I didn't. Well, I will probably have missed something. Like go back to this to the break. Sorry about that. And yes. So we already, before looking into view binding, that the idea is that not use the find view by ID, or what we already saw of the Kotlin synthetics, that it was the procedure of calling the widget from the activity just by entering the ID instead of doing the find view by ID. And Butterknife, it's kind of not so much used anymore, so I will not even mention that. So the main advantage of using view binding compared to Kotlin synthetics, it's null safe and supports both Kotlin and Java, and you typically need, well, I think this similar amount of code. And yes, and the second part is data binding, which is not the same as view binding. So we saw the second lecture, not sure, the model view controller, and you would have your controller would be your activity, and then it controls your view, which typically your XML file, and then the model that we define as our data class. For example, for the Olympic quiz, the question was part of the model, then our activity was the controller, and then the XML was the view. So it works fine, but the problem arises when your project grows larger. And this is just one tip, that if you use view binding just to avoid using find view by ID, just for that purpose, it's better. Just it's not recommended because it would add extra complexity. It's only when your app grows and it involves like more user interface. And so related to what I said previously, the model view controller is an architecture, and is, as some other, they should follow the single responsibility principle, and that is each class should have only one responsibility. So what in the model view controller for the app that we define works fine, but it's not always the case. Yes, I think, and the thing is that having that in mind, sometimes when your app grows, you may, if you use the model view controller, we'll see now an example that you may be accessing the XML from different class, and that's kind of not appropriate. So for that is what is called the model view model. Yeah, so I think I will. Well, first, because I have an app to show the example. Not sure if this. Yeah, so I will try to plot this quickly. So the app that I'm going to show is just has one XML that you select one button, and every button corresponds to a song that is going to play. That's basic. So several buttons, you click on button, and some sound is going to play. So it has a list. So the XML, let's call it list XML. Well, if we want to use data binding, you still don't know pretty much what it is, but just follow it here. So if we want to use data binding, we want to interact with our list in our XML file, we would have to define, I call that class song, which corresponds to a song that we are going to play when we click on any button. And then, like, we also have our controller that, like, as usual, would be our main activity. However, now this model view controller is broken because we are controlling the XML with the song file and not through the main activity if we are using data binding. So the solution would be to use our XML file list. Then we would have to create what is called the song view model. And then we'll have here our class that defines a song. And our or some view model will have the only task of observe properties of the list, and the sum would observe the and from the sum we will send the callbacks to, in our case, would be change text in the buttons or respond to an on-click. So callbacks and listeners. I think if we go to the app, okay, I can understand that this is like, this quickly maybe not that easy to follow, but I think my goal is so that you have a general idea of what it is, and if you want to look more in detail, have a look at the app, and I will come back to this app when we talk about Recycle View. So to enable the same as before, we have to enable data binding, as we did before. And with view binding, we didn't have to do anything in our XML. So if you use view binding, you don't need to, but for data binding, if we have our layout, yes, this is our list of songs. We have the way we bind data to our XML is we define a binding object in our XML. We have this name view model. So you would have to add this binding object in the XML. And then with this mustache operator, you would bind your XML to the data that you want to use. So in this case, we have the function on button click and the property, like the title of the song. So I want to try to explain the main concept because it's not that easy to follow just in like 10 minutes, but we'll have our main activity that, because we are using a recycle list that we will talk about some like 2 lectures from now, we need an adapter for our list. So that's the main concept here. I'm going to run it in the meantime so that you see. You will have our main activity. We are creating the adapter for our list of songs that they are displayed in buttons. Then we have our song class, that the only property of the song class is the name of the song that I have placed in the asset folder, correspond here. That's the only thing we need to know about the song. We could also add the duration, but we have the name. And then we need our view model. Don't get confused with what we saw second lecture. View model. View model is a library from Jetpack, and this is a different, similar concept, but it's different. This is a view model implementation for data binding, which is not the same that the view model that we use in the second lecture. So our some view model, we have here we can access here the title and the function that when the button is clicked, we play the song. And because we are using data binding, the key concept is that we will need to add the binding object in our XML, and then we are removing that task from our main activity, and we are not. So before we would have our function of on-click and the function to play in our main activity because it was our controller, but because we want to take that task out of the controller and out of the main activity, we create this some view model that is in charge of interacting with our XML with the binding objects. that's the general idea. And yeah, so that when you click it, I'm not going to click because it's going to play some, well, I think, yes, you may hear it. That's all the app is doing. And the app is on Canvas, and I wanted to give like a very brief introduction to data binding and view binding. I will solve the issue with the other example before that, I'm not sure. And one other concept that you will see is in the app is observable data. That the idea is that the view model can communicate with the layout when a change occurs. And you have to implement the observable interface. I think maybe in the break, if someone has questions, because I don't want to spend more time on this, I don't want to give that much importance. But the app is on Canvas. I will go back to it when we talk about the recycle view, and because that lecture will be only about Android, I may give some more details, but because someone asked, I thought I would at least introduce what it is. Yes, so one summary or comparison between data and view binding. You would use view binding for simple user cases because it's faster compilation and easy of use. As I said, you don't need to add that specific tag in the XML, so it's faster to adopt in your apps. The reason why you would want to use view binding is because you want to support two-way data binding, and when you are using the model view model architecture for your app, that in the app that we are doing this in this course, they don't involve that much complexity. So we can use our model view controller and it's going to work fine. But yes. So yes, I think I already spent more time than I wanted, but yes, that's. So one other comment is I would switch from our model view controller that works fine when you realize that you have one activity or one class is having more than one task. You are accessing the XML layout from two different classes. At that point, you may like stop and think that that's not appropriate, and you may want to switch to the model view model, because every class or activity should have only one main task. So, but I think the complexity, the app for this class, I think with the model view controller, it's going to be a good fit. And so summary from the sensor from last week, because it's also needed for the assignment for starting this week, is that I think I didn't mention this, but so when you define the, I think, yes, yes. When you register the listener, you can specify like with a float the specific delay, and that's it. How often do you want the sensor to get a reading from the sensor? And you can also specify, instead of like writing the particular number, there are some predefined delays that the normal, the game, the user interface, and the fastest.
So, Professor,
yes.
when I click in one of the links, they all showing on the same content. Is that supposed to be? Is that what it's supposed to be?
Here in this slide?
Yeah.
Yes. Because I think, I don't remember exactly the link, but it will take you to the Android official documentation or where they talk about the sensors. So I think it's the same. Yes.
Okay.
Thank you for nodding. But yes. Another function that I didn't talk about last week is the get delay, that you can get that, call that function to know the minimum delay or the time interval that the sensor in your particular phone can use to sense data. Yes, and depending on the value, it can give you the idea, the definition, whether the sensor is streaming sensor or not. And then a sensor that is not streaming is when it returns you 0 for the get minimum delay, and it will only report data when there is a change in the parameter. For example, the step sensor is a non-streaming because only when it will produce a value reading from the sensor when there is a change. Yes, so that's, I hope you got the feeling of a little bit of data binding, a bit binding, even if I went very quickly. But the part of today, it's about a very practical introduction to deep learning for Android. So the motivation is to be able to run your own custom model in your app. For example, in the assignment that you were doing the face recognition, if you were seeing in the console, it was actually running. You could maybe see the name of the TensorFlow Lite model. You were running some model from some external library, and you only need to know how to prepare the input for that model. In that case, was very simple, just a bitmap, and with that you could call that model as if another function that the input is a bitmap. In the assignment for this week, you are doing some detection of some well-known, a known simple gesture like step or pull-ups or shake, and you could do some kind of basic signal processing and you could get a fairly good accuracy. You don't need any fancy model or just some by analyzing the raw data from the accelerometer. But what if you want to, instead of detect pull-ups, what if you want to do like any other custom gesture? Then doing some heuristic, and that, as you were doing for the assignment, that maybe not get good accuracy. And maybe there is not an external model who does what you want to do. For the face recognition, it's a traditional activity that there are already models for that. But if you want to, in this case, detect your own custom gestures, there might be not an available model or function that you need. So that's kind of the motivation of this topic, and also because it's more and more, it's been possible. There are more and more models are appearing for like different activity recognition or like classification of data or generating new data from previous data. And traditionally, you would do that with some other library, but recently it's been done more with deep learning. So I think it's important that even if it's only one assignment, and I don't think you will use it for your final project because it's maybe a bit more advanced if you don't know about deep learning, but I think for one lecture, it's interesting that you go through the whole process at least once. And yes, the way I prepare the lecture is that you don't need to know all the theory to start like building what we are. I'm going to provide the model and most of the tools that you will need. So if you are experienced with deep learning, I think this is going to be a fairly easy assignment. But I think at least if you don't implement everything, you go through the process from defining a custom gesture to actually have an app who detects and classifies that. And I also prepare just assuming that, well, some of you have no experience in the topic, some brief introduction that maybe sometimes confusing the difference between artificial intelligence, machine learning, and deep learning. Sometimes people like talk about if they were the same thing, they are exactly not. So artificial intelligence, it's basically that enables computer to mimic human behavior. Then a subtopic is machine learning, that you want to learn without explicitly being programmed. And the concept learn is the key here. And one area of learning is deep learning, that you extract patterns from data using neural networks. And you can extract patterns to classify data or to generate new data. And so what we are going to do is build a neural network model using like deep learning. So, and how in practice is typically done with Python and TensorFlow. Why now? Well, I think this is more like a general introduction. One limitation with deep learning years ago is that there were not enough data available, and you need typically like a good rule of the thumb is the more data, the better. So there are more data and the hardware is much more powerful, a wider community working in that investment. And I'm not playing the video for time constraints, but like I always like when see also like the why not, because deep learning kind of, it seems like it's growing. I heard like in a talk that someone said, I don't remember, that years ago people said that software would eat hardware, and now they say that deep learning would eat the world. But it's good, but what are the limitations? Why would not use it? So for example, the Boston Dynamics robots, it hardly use deep learning, just for some very trivial visual perception. It's mostly based, and the same with self-driving cars. It's mostly, they use some, like a very small amount of deep learning. They mostly use model optimization. And also, if you look at this game, sometimes it can have unintended consequences. The game is, you have to win the race and you get points by like doing different tasks. So I can quickly, I think it's very short, and just to, so in this game, it's using some deep learning model. So this player realized that it can get more points, not by, instead of winning the race, it realized that the way you get more points is by getting those green like guys. So it keeps indefinitely doing that. That's another introductory slide. Is there are three main classes of learning problem. Supervised is what we are going to do. You have the data, you have the labels. An example, the data is the picture, and the label is this, it's a 3. And supervised is when there are no labels, and then you can learn underlying structure. And the example is, the output would be, this thing is like the other thing. And the reinforcement learning is typically used in robots, and it's used to mimic, it's used to take action based on a reward. I take, for example, the game video that I showed before, it was taking that action all the time because it will give it more reward. So the example would be select this number because it will make you go forward or get more points. So we will be using data with labels to classify. And now, because I really want you to go through the all process from the idea of what you want to classify until the Android app that does that. I have some slides about how to go through all the steps. So the first part has nothing, it's not related to Android because you can deploy this in Android or in a computer or in a microcontroller. But I think it's important at least that you learn, you know more or less what you are doing. So it can be, we are going to follow 7 main steps. First, decide on a goal. The class activity would be to do some digit classification. And the assignment is going to be classify a custom gesture with the accelerometer. Then you will have to collect some data set. And with that data set, you design the model and train the model with that data that you collect. And then the 5, 6, and 7 is where we are going to focus it on Android. We are going to convert the model so that we can use it in our Android app. And then you run inference in that. And by that is basically you take the model and then you provide some input and then get some output. And this. So the way I organize that is that we are going to go through all the steps, and at some point, some of this, I think point 3 or 4, you are going to work the first part of the class activity. So I will show you how you are going to do it. And then we will come back, we will finish this, and then I will introduce the assignment. So in the first part, we are going to do the handwritten digit recognition. To process that, we are going to use what we did for the Pictionary app. We are going to create an image from a digit that you write on the screen, and then you are going to, that bitmap is going to be the input in our model. But if you think about, well, you already realized this in the last assignment that images are numbers, it's just like pixels. And pixel is a number between 0 and, in this case, 255. And then the model of our digit recognition would be this whole vector of all the values of the pixels. I have, I think, the app here. We can run it. It's going to run the app. So this is the app that you are going to do. Well, don't feel, I hope this is not like feeling overwhelming for people who have no previous experience, but I think I'm going to give a like so practical introduction that I think is going to be good to follow. So for this activity, I provide the app. I think you only need to insert the model that you define. So for example, it will be like 3, and it's going to predict the result of 3 with some confidence interval. And for the, yes, if we look at the activity now that I remember, in the assignment from the last week, yes, most of you just for using the model, the code that I provided, have implemented this on Touch Listener, even though you didn't use it, and here is when we are actually going to use it, so that you start drawing, and when you stop drawing, when there is an event of action up from the user finger, the click event, we will call the method classifying. Yes, that's when we are going to feed the bitmap, convert it into a float array to the model input. But you are going to see in detail this in some minutes. Yeah, so that's the app that you are going to do, but you are going to train the model and then include that in the app, because the app that is on Canvas, I remove the model so that you can go through the steps, create the model, and then put the model into the app and then run it. And that's what you should expect to see. I have prepared some, especially for, like, assuming that at least half of you don't have experience with this topic, some videos to make it a bit more, not that, like, not boring, but maybe not that interesting to follow. Some quick videos. I think I have 2 or 3 with some part, but we are not going to play everything. Yes. So the first part is decide the goal. In our case, we are going to build, this is like a well-known problem for starting with this topic, do the handwritten digit recognition. So that is some video that I think provides a nice introduction.
The 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do
this. It doesn't start what I said.
Are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons. And admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with the specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here has already been trained to recognize digits.
I think that's enough. So I remember when I first learned about it, well, not even when I learned, before, when you heard about it, it seemed like it's magic. How can it be possible? But it's actually just like a bunch of maths behind. Can be more or less advanced maths, but it's mostly maths what is behind. So yes, what we are going to do is a classification problem that we have some input data, and we are going to get what the probability that this data fit in each of the classes. In the digit recognition, the classes are 10, from number 0 to number 9. And the assignment is going to be to recognize 2 gestures. One that I define win, and the second is like no gestures. Then the second part that is important is collect data set. And I think this is one of the parts that provide a jump in the in the more and more use of deep learning. That we need some data set so that our model can learn. And the concept learn, it's basically, well, we will see it in the next slide. We need some data so that our model can know, okay, this is the data, and with this is the label. So I want, if I get new data, I have to classify this new data based on the previous data that I had for training. Yes, this is what I mentioned, that generally, like, it's not always true, but yes, in general, the more data, the better. For the digit recognition, you will see that we will use a well-known provided database. And for the gesture, maybe it's not that accurate because we only have, I don't remember how many trials of the wing gestures, but it's a bit more limited. And we need to label the data. So we need to gather so imagine that we had to do the data set for the digit recognition from ourselves. You'd have to maybe just create a different picture with the digits and label, give them the label. This is the 0, this is 1, this is 3, and just have like as many pictures as we want with the digits with the corresponding label. The third part is we have to design a model architecture, and this is already given to you for the assignment, because that, as I said, this is a bit outside of this class, but because it's related, we are doing an assignment, but I provide you with the model. But so that you have an idea, it's basically simulated neurons that they are represented in arrays, and you typically organize them in layers. You have the input, the output, and some layers in between. And this is not like an exact science of how many, for this problem, how many layers do you need? So it typically depends. So the number of layers may depend, and you may, once you define the model, you train it, and you may like redefine or change the number of layers. So I think, yes. So it's neuron, like the guy in the video mentioned, it's like a thing, or I think a guy that holds a number, and they are represented by what is called weight biases. For now, just keep that word in mind. Yeah, so when the data is fed, it involves some readjusting of the weight biases. And the weight represents how much is likely that this particular neuron will be fired. Yes. I think to better, well, not to be, I really like this video because they represent a very visual intuition. So for the first approach, may help you to understand the concept of the weights. And I think, yes, well, this is from minute, I think.
Picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then take activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own. And I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about. And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range between 0 and 1. And a common function that does this is called the sigmoid function, also known as a logistic curve. Basically, very negative inputs end up close to 0, very positive inputs end up close to 1, and it just steadily increases around the input 0. So the activation of the neuron here is basically a measure of how positive the relevant weighted sum is. But maybe it's not that you want the neuron to light up when the weighted sum is bigger than 0. Maybe you only want it to be active when the sum is bigger than, say, 10. That is, you want some bias for it to be inactive. What we'll do then is just add in some other number, like -10, to this weighted sum before plugging it through the sigmoid squishification function. That additional number is called the bias. So the weights tell you what pixel pattern this neuron in the second layer is picking up on, and the bias tells you how high the weighted sum needs to be before the neuron starts getting meaningfully active. And that is just one neuron. Every other neuron in this layer is going to be connected to all 784 pixel neurons from the first layer. And each one of those 784 connections has its own weight associated with it. Also, each one has some bias, some other number that you add on to the weighted sum before squishing it with the sigmoid. And that's a lot to think about. With this hidden layer of 16 neurons, that's a total of 784 times 16 weights, along with 16 biases. And all of that is just the connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases, 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways.
We'll stop it here. So I think in this video they provide like a very good visualization of the weight and bias. So you may be wondering, like, if you are new in the field, like, how do you set those? Because it's the key, the weight and the bias. So one approach is you initialize them randomly, and the concept of learning, you can think of how to set those weight and biases so that for a particular input, only particular neurons are activated, and then the output with highest probability is the one that you want to do. So that's, like, for a general idea of learning, is how to set the values of the weight biases so that it learns to recognize the data set for it was trained. I don't want to spend more time. Oops. Yes, I will. I didn't want to get more in maths, but just only one, so that you get to see better the concept of the weight bias. So I will show it for one single neuron, but it applies for. So if we have this one, these are the different inputs. You can think of them as the 1 and it would be until x 128, all the different pixels in our pixel values in our input, then they will go into a sum. Then you apply some nonlinear function. I think in the video they use a sigmoid function, and then this will give the output of that one neuron, and this will propagate through the next. And this then would be computed as this nonlinear function that I think in the model that I provided, they use ReLU. I think I have one slide, but it's a nonlinear function. And then you need some bias. So it would be the bias plus the weighted sum of until m. This would be m of the xy plus the weight. One thing that so these are the weight. So what it is unknown here, so m is known because we know the size of the input, we know what we specify one particular function, but we know the input because it's what we are providing for the model input, but the key is defining this weight and bias so that every neuron for a particular input, only the neuron of interest are fired. But yes, that's all about maths. So in the assignment, because I think it uses two. I think one of them is going to use this ReLU. So the idea is that for every input lower than 1, lower than 0, it's going to be 0, and if it is greater than 0, then keep the input value. Before, like sigmoid was used like traditionally, and it's been more and more models are starting to use this ReLU, and these are some other variations. And this is the other function that is using the models that I provide. Yeah, so it's not yet for the activity. So this is the model that we are going to do the first part of the group activity. And it has the input layer with all the pixel values. It's called Flaren because we are basically putting in an array all the pixel values. Then we use a dense layer. Dense layer means that we are connecting every input to all of the neurons here. So for example, pixel 1 is connected to every single one of the 128. Yes. And the last layer.
I'm just checking the Jupyter notebook, and it's the other way around. The dense one is using the ReLU. The activation it's kind of the other way around. Is that
okay, so this is using ReLU and this is softmax.
Yeah, that's the other way around.
Yes, and maybe switch it when put it into a slide. Okay.
Okay.
No, what it is in the, I will trust more that because I prepared this after preparing the model. So this is probably the slide I maybe switch it is, but thank you for knowing that. You see like TF, you will see in the, I think in the document that I provide for training the model is a remote processor, but I have some instruction and some more detail, and TF comes from TensorFlow. It's a set of tools for dealing with neural networks, because you could, if you did, you could actually, the key here is that this is like a lot of maths behind, so you could implement this manually by yourself. But if you use some kind of tools as TensorFlow, you can just write dense, the activation, and this is what you have to completing the activity, the number of neurons, and it will create those kind of connection for you. So that's why I said much earlier that you don't really need to understand in depth all the maths and everything behind. If you want to really get a, like, well, at least for starting, if you know more or less, you have a general understanding and you know the tools, you may be able to like define a model. Because there are like very good tools and APIs as TensorFlow and Keras. Keras is a set of APIs that you can use with TensorFlow for dealing with deep learning, and it makes the work a lot of much easier. And we'll first create this dense, fully connected network, and in the last part we will change the model. Yes, this is one key that for designing the model architecture. There are like many free and available models, and we use one, for example, in the assignment for face recognition. And there was one also other things that they may not be available the model that you want, and also you are relying on a third party for that, as some of you have troubles with running the face detector. And yes, the name of TensorFlow first, yes. Yes. I don't want to give too many like terms, but a tensor, you can think of a tensor as an array of numbers when you see the term tensor. No, okay, not yet. Yes. So okay, we have our goal. We are going to classify the handwritten digits. We are going to get in Android. We are going to get the bitmap. It's the picture of the black and white of the drawing of the digit. But then we need to put that into that 784 numbers of the array. That's what we are going to use to feed our model. You could think of defining a different model, or yes, that it could get as the input would be a bitmap or any other structure, but then you would, at the end, you would have to convert that to like an array of numbers. We have our goal. We have the architecture first, because we are going to build this exact model. For the data set, we have the data set because it's free available. There are some well-known data sets that you can find online and just download. For example, if you want to work with traffic predictions, there are a lot of traffic data that you can use. Yes, there are things also for weather, and for this case, it's a well-known data set. We have the model, the data set, the goal, and then we have to train the model so that it can learn from the data that we have to be able to classify new data. Yeah, so typically you would start your weights with random values and the bias 0, and then when you train, the idea is to tweak those weights and bias according to the data set, so that it can learn when to fire the particular neurons. And I have the concept in the other slide. Some keyword that you will see will be back propagation, and it's not in here, but then I will mention it later. So batches, typically you don't want, if you have like a very big data set, you don't want to fill the whole data set at once. You will break the data set into parts or batches. And then the way to, the concept of learning, it uses what is called backpropagation. It's to adjust the weight and bias. And because I wanted to give just a brief overview of what is backpropagation. I will show it in a video in a few minutes. And then just know that the concept of learning and backpropagation is to adjust the weight and bias so that, well, I think in the video they say that, but so like intuitively, you know that when you get this input, I get the input is a 3. And then you know, because you are, that data is labeled, that the output should be 3. Then if it is not 3, then how would you need to readjust the weight and bias so that for this input, I get the output in particular? Because if you initialize the weight and bias randomly, when you get this input that you know that is a 3, the output may be random. So, but because you know that this is a 3, how would you adjust those values so that the output is a 3? So then you would have to, so it's a function minimization because the output is a number, and in the middle is like a more or less complex function. So it's minimize the error between the input and the output. This is the intuitive idea, but I think you will not have to like worry about like backpropagation of the learning process or in the assignment, but at least so that you get a general idea. And this is.
So here, we learn how the network learns. What we want is an algorithm where you can show this network a whole bunch of training data, which comes in the form of a bunch of different images of handwritten digits, along with labels for what they're supposed to be. And it'll adjust those 13,000 weights and biases so as to improve its performance on the training data. Hopefully, this layered structure will mean that what it learns generalizes to images beyond that training data. And the way we test that is that after you train the network, you show it more labeled data that it's never seen before, and you see how accurately it classifies those new images. Fortunately for us, and what makes this such a common example to start with, is that the good people behind the MNIST database have put together a collection of tens of thousands of handwritten digit images, each one labeled with the numbers that they're supposed to be. And as provocative as it is to describe a machine as learning, once you actually see how it works, it feels a lot less like some crazy sci-fi premise and a lot more like, well, a calculus exercise. I mean, basically it comes down to finding the minimum of a certain function. Remember, conceptually, we're thinking of each neuron as being connected to all of the neurons in the previous layer, and the weights in the weighted sum defining its activation are kind of like the strengths of those connections. And the bias is some indication of whether that neuron tends to be active or inactive. And to start things off, we're just going to initialize all of those weights and biases totally randomly. Needless to say, this network is going to perform pretty horribly on a given training example, since it's just doing something random. For example, you feed in this image of a 3, and the output layer, it just looks like a mess. So what you do is you define a cost function, a way of telling the computer, no, bad computer, that output should have activations which are 0 for most neurons, but 1 for this neuron. What you gave me is utter trash. To say that a little more mathematically, what you do is add up the squares of the differences between each of those trash output activations and the value that you want them to have. And this is what we'll call the cost of a single training example. Notice, this sum is small when the network confidently classifies the image correctly, but it's large when the network seems like it doesn't really know what it's doing. So then what you do is consider the average cost over all of the tens of thousands of training examples at your disposal. This average cost is our measure for how lousy the network is and how bad the computer should feel. And that's a complicated thing. Remember how the network itself was basically a function, one that takes in 784 numbers as inputs, the pixel values, and spits out 10 numbers as its output. And in a sense, it's parameterized by all these weights and biases. Well, the cost function is a layer of complexity on top of that. It takes as its input those 13,000 or so weights and biases, and it spits out a single number describing how bad those weights and biases are. And the way it's defined depends on the network's behavior over all the tens of thousands of pieces of training data. That's a lot to think about. But just telling the computer what a crappy job it's doing isn't very helpful. You want to tell it how to change those weights and biases so that it gets better. To make it easier, rather than struggling to imagine a function with 13,000 inputs, just imagine a simple function that has one number as an input and one number as an output. How do you find an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make that output lower. Specifically, if you can figure out the slope of the function where you are, then shift to the left if that slope is positive, and shift the input to the right if that slope is negative. If you do this repeatedly, at each point checking the new slope and taking the appropriate step, you're going to approach some local minimum of the function. And the image you might have in mind here is a ball rolling down a hill. And notice, even for this really simplified single input function, there are many possible valleys that you might land in, depending on which random input you start at. And there's no guarantee that the local minimum you land in is going to be the smallest possible value of the cost function. That's going to carry over to our neural network case as well.
I think with these videos and the model explanation, I hope you had at least a general overview of the model that you are going to use and how it works inside. I think yes, because I think I remember when I first heard about it. If you have no idea about this, is seems like might. How is this model of software or computer is going to learn? But the basic is if you have data that you know the output and you have a different output, is just to change so that the input and output matches. So it's minimizing a function that minimize the error because you know the input and the level data.
And I also want you to notice how.
Oops. Yeah, so when we start training the data we train the model with the data, we feed with the data, and then we propagate the error, adjust the bias and weight for how long. So typically you want to stop when it's converged. That is measured with the loss and accuracy, because you will see these two terms when you go through the assignment and the activity. So the loss is an estimate of how far the model is from producing the expected answer, because we know the input because we have labels for the input data, and the accuracy is the percentage of time that it chooses the correct prediction compared to when it doesn't. And the perfect model that would have zero loss and accuracy 100%, but models, as you may be wondering, well, not wondering, but assuming that rarely are perfect. So that you see it plot for an example, the epochs, it's the number of times that the whole data set is fed through the model. Because I said typically you want to break the data set into parts, that is called batches, but the epochs refer to the whole data set, how many times it is fed forward and backwards to the model. So as you start training more and more, the loss will typically be reduced close to 0, and the accuracy typically you want as high as you want to want. Yeah, and typically, this is not like exact science that I have this problem. Okay, I know from theory that I have to use this model with this. Typically, you have to train, try the model, and then adjust the model. For that, there are what is called hyperparameters. That is like the number of epochs and the epochs. Sorry, they repeat how many times you feed the data and how many parts you break the data set. So you can tweak those parameters to improve the accuracy, reduce the loss, and increase the accuracy. And yeah, I think this is the last slide that I was thinking about. So typically you would have the whole data set, and then you would want to break it into batches. It's a small part of your data set, and one epoch is all the data set is fed through the model. And then other part related to training the model is why could the model fail? So there are two main concepts that I briefly introduced in is underfit. So it typically happens when there is not that much data provided. So the architecture is like too small. Maybe you don't have enough neurons in your layers. So I have then a plot that you can see the effect in maths. And the other problem is overfit, that it happened when this trained data too well. So if you, for example, you are trying to recognize for the handwritten digits, for example, if you have for the number 1, all the data set that you provide, the number 1 is pretty much the same alignment, then it's learning the data too well, and it means that if you provide a different number 1, instead of being straight, is a bit bended, it may not be able to recognize it properly because it has been trained too well for that particular type of data. So it's not able to generalize for new data. Yes. So in a picture, so underfitting, you may have this picture that the model will not learn the data fully. Overfitting is that it's learned that data too well, so it may not be able to generalize for new different data. And the ideal fit would be something like this. Yes, in an example for the validation and training, first you will train the model, and then the loss would be like close to 0. But then when you get different kind of data for validation, it's going to increase considerably the loss because it's overfitting. I think too many concepts in here, but at least that they are familiar to you so that when you see them, you know this refers to this. And if we want to prevent our model from failing, we want to typically, well, if it is underfit, you could typically fix that by training with more data. But it is overfitting.
That was made.
You would approach the concept of regularization. And there are the different techniques, L1 and L2, but the one that you will have in your model will be using dropout. Is you are just randomly cutting the connection between some neurons so that some neurons are not activated, or data augmentation. is that you artificially expand the size of the training data set.
We're gonna do like we change the vehicle.
Yes, the last part is once you have the whole data set for training the model, you would want to break the data set between training, 60% of the data, 20% validation, and 20% test. Because if the thing is that if you take the whole data set and you train the data set with all of that, then you will not have more data to actually check if it's working properly. That's why you first train the model with that 60%, then you use 20% for validation, and that data is different from the previous one, so that you can check if the model is behaving or not properly, because it's different data. Because for the class activity, it's not breaking in this part, but for the assignment, it's breaking the data, I think 60, 20, and 20. So that you know why it's important to break the data. Yeah, during training, use the training data set, and yeah, so you want, I think that this is what I said, because you want to feed the data with, once it's trained, with new data, so that you can see if it is able to performing well with new different data, in case you want to adjust the model. That's it. And I think, yes, right before going to the activity, and now it's from here, now we will see the relation with Android. But I think it was important for, more and more you will see apps for doing like signal processing that are using neural networks. So you can, recently they released some paper that they were able to detect heart failure by EMG data using some neural network, and you could run that model in Android in a phone or in a microcontroller. So I think it's important that, because it's becoming more and more useful, so that you go through the process, and at least for some of you who, with no experience with this, feels like you get an overall idea. So if you want to develop, once you have your model, TensorFlow, as I said, is a set of tools for like building and training machine learning models in general. It was developed by Google, but now it's open source, and it's the most popular framework, at least that I know. And the good thing about TensorFlow is that it has the set of tools called TensorFlow Lite that is able to convert the model, because if you use traditional TensorFlow, the model is too big for running into Android or a microcontroller. But you need to use the TensorFlow Lite converter, and then it will convert the model into a light version without losing accuracy, so that you can run not only on Android, but like new microcontrollers. Even with Arduino, they have the option of including a TensorFlow Lite model into Arduino and run some model. You need to, if we wanted to run our model that we have in our phone to the microcontroller, you would need to do a step further. It basically generates some C files, and then run that into our microcontroller. Or Arduino 2, for example. The thing that the Arduino that we have for this class is it's not too old, but it's not that new. And it does not support TensorFlow Lite models, but maybe if we want to buy in the future new, would be also a good assignment to do some, because it would be interesting of doing some like gesture recognition with the Arduino. But you could also, no, because I think the data from the accelerometer would be like different, the way you move the Arduino with the phone. But the summary is that you can run the model in Android and Arduino with TensorFlow Lite. And if we get new Arduinos in the future, we may try to also run it on the Arduino. And Keras, you will also use Keras. It's a high-level API that make it easier to, we'll also use, there is something more. We will also use with TensorFlow. Yeah, so let's 7:30, I think. I think because the last part of the lecture is once you have the model, well, there are two parts. One is neural networks, well, convolutional neural networks, but these few slides, and then how to run that model into Android app. So I think we have time. And we are not I'm not going to have any specific breaks. Yeah, during these two class activities, just take the break as you want. So I will give half an hour now, and the next part will be quicker, so maybe like 20 minutes. But the activity is already on Canvas, and I will, this time I open a submission on Canvas so that you can submit if you finish it, submit it on Canvas, and again, I will give 5 points to the best solution in time. And oops, this card. I wanted to open. You will be using for this assignment and the assignment and the activity, what is called Google Colab. The main advantage of this console is that you can, I have this on the middle. Yes, you can connect to a virtual machine and, oops, connect, yes. You would, if you should enable GPU so that it's going to run faster, and without having to pre-install anything in your machine, you can run TensorFlow in here. So you would, if you Google Colab, you would get quickly through the main console, and then you can click on File, open Notebook, and you can mount your Google Drive, and the files that here is where you see the file that, if you generate new files, and here you can mount Drive. If you want to have this in your Google Drive, you can also download the file to keep it for later. And there are some comments in here. I think it will help you to follow the steps, and like this organized in cells. So to run the code, you just have to like click on this icon in here. And yes, the activity would be to follow this Colab Jupyter notebook. And I also, but for now, just do part 1. And well, if you finish earlier, just continue part 2 and 3. And the app that is on Canvas, you will need it for the part 2 or 3. So I will give now half an hour, and then I will ask if all of you have even started the last part. Maybe the last part I will give like 10, 20 minutes, depending on how far you got here. I prepared this activity in class because for the assignment, you will have to also run a similar notebook, but for a different purpose. So if you get familiar with this environment for the activity, then it would be very quick, much easier for the assignment. And if anyone has like problems with like getting in the Google Colab or running the cells or any other issue, just click on the help icon in the breakout rooms, and I will go into the room and try to solve that. So now only do part 1, and maybe have half an hour, maybe too much, but in case there are some issues, but you can also take some like 15-minute breaks if you finish earlier. So I'm going to assign again the breakout rooms randomly. I want to open here. Any questions? Or 'cause I didn't stop talking since I started, but I always want to prepare like too many things, and I forget that sometimes I have to stop and ask for questions instead of just keep talking all the time. But yes. So if someone asks if, like, instead of using Colab, you can use, yes, you can use any platform that you want. I just provided this because I think for first approach is easier. Anyone has worked with or doesn't have any pre-installed like software in the computer, but I'm going to ask for the app and the model, so you can use, if you don't want to use Colab, you can use other platform or software. So I think for those of you who have quite some experience with deep learning, this may be like very easy, or not easy, but you may do this quickly. But I wanted to approach like all the class, assuming that, well, I know that some of you have no experience in this topic. So let's around 8, 5, I will announce, or if some group finish, just go back to the main room, and I may finish earlier if all of you finish earlier. But around 8, 5. So I will create rooms. I will stop the video now. Okay. So, well, in general, it was like some of you did pretty good, and something I wanted to comment that app for the face recognition that we did was a very good example, or where you could use a fragment, because like left hand side was the exact same layout, like the image view or the draw view with the button. So you were duplicating code and XML. So you would just have one fragment and include the same fragment on the right and left. And with the same Kotlin code, you could just control the two fragments. So that would be a good example of where it could be used. And the other thing that I wanted to comment that, like, I'm not going to like remove points for like duplicating code. It's fine. I'm just like looking for functionalities. Sometimes when you read the assignments, you may be thinking that I don't specify everything, and it's not because I'm lazy when preparing the document. It's because I want you to think a little bit out of the box and thinking, okay, I want to implement this. What user interface or how should I implement this? But it's some part of avoiding code duplication, specifically with if you want to have the same code for two buttons, you can call, in the solution that I provide, you will see, you can call view.getID, and you can find which button got that click event. Instead of having the onClick for the two buttons and duplicating the exact same code, well, you may change one line, but you can get, with view.getID, you can get the ID of the widget that call that onClick function. Some of you forgot the permissions in the manifest for the camera, so it crashed. So don't forget, if you use the camera, have the permissions in the camera. And that's something that I saw in this assignment and the previous one. So some of you include in the manifest the option of the unsafe. I don't remember the exact syntax. I forgot the specific. The configuration change, so that when there is a configuration change, such as rotating the phone or some other, you don't want to call the onCreate again. You don't want to restart your activity. But then in your project, you create 2 different XML, one landscape and one portrait. And you expect that when you rotate the phone, you will pick the landscape and the portrait, but it's kind of incompatible. It's not the app is going to work fine, but doesn't make much sense to have that in the manifest and then have the 2 XMLs. If you have the 2 XMLs, portrait and landscape, it's because when you want that when you rotate the phone, you want to use the portrait on landscape. But if you have that in the manifest, it will always have, it will not change the XML, because the XML is set on the view when the activity run the onCreate. So yes, I saw this in this assignment in the past one, that you have 2 XMLs, but then it doesn't make sense to have that in the manifest file. So if you want to use portrait and landscape XML, when you rotate the phone, don't include that in the XML, because it will prevent Android for changing the XML layout when you rotate the phone or other configuration change. I think, yes, most of you, well, some of, not, I don't remember how many, but the idea of saving the picture was not to save the bitmap or passing the bitmap to another activity, was to save because we are in the app, I gave the code to save the image or the picture in the phone gallery. You can access that image with the URI. So the idea was to save the URI of the picture so that you can't recover it when you, like later, I mean, when the onCreate is run again, or the unsafe instance instead. Other thing before we go back to the slide, I share screen. Screen. So share. I'm sorry about all. So the first time that I tried to do the online examples, so I'm sorry that like I have all these. I think maybe next year, now that all the issues are solved, will be better, but things not working and those things. So I found out the issue with the view binding. So yes, going back, we want to avoid calling the find view by ID to the XML widgets, and we also want to avoid the Kotlin synthetics that we just use the ID in the main activity. So we import in the Gradle the view binding, and then we did that before. We create this binding object, and this is the name of our binding class. And this activity is created by Android when you enable the binding view, the view binding, but it's also going to create an XML with the binding properties. So you would binding dot the name of the binding XML, and then this is the property and the text. And this, by convention, would be this ID that you put here with lowercase and uppercase. So if we run this app, it's going to crash, I think, because I was playing with other things, but you could actually see that text there. And the last part is to inflate the view. So if we are using if not using view binding, we would set this set content view. But if you are using view binding, yes, the way of setting the layout is set content view binding is this binding object dot root. Yes, so anyway, I will talk a little bit more about data binding with recycled views, but I think this is, I'm not going to ask for like data binding or binding, but some of you may want to use it in the final project if you are more experienced with programming. So yes, I think 15, we have 1 hour. Yes, I think we have. Well, let's finish this, and then when, depending on how far you got in the first part, I will briefly ask. I will give more or less time to finish. And it seems that it keeps the breakout room, so you will be able to join the previous room, because I didn't have enough people to try this before. So yes, in that first part of the activity, you develop a basic fully connected model for training the hand-written digits. And you didn't get to the part of actually downloading the model, because that model performs good, but we could do better. And the idea is to define a better model. And that's what we are going to do in the second part. And then you will download the model file and then integrate that into your app. And that's what we're going to see in these slides. I already mentioned the TensorFlow. We are going to use the interpreter. Yes, I have this in the middle. Yes. The light converter, that is to apply the model to like devices with a lower computation capabilities, such as smartphones and microcontroller. And well, you would consider Arduino as a microcontroller. But the part of adding the option, well, the feasibility of running TensorFlow or like deep neural networks model in microcontroller is kind of recent. So maybe like 20 years ago it was, well, maybe not, 20 years ago it was definitely not possible. So it's like very interesting area to work on. Okay, now that we have the model, I'm going to show it's very easy how to integrate that into your app. But the key thing when you want to run inference, so you need to have the code that takes the raw input data from the sensors, or in general, and then you have to put it in the same form that our model was trained on. So you train the hand-written digits as the input was an array of the pixel values. So if you want to use that model in your Android app, you have to convert that bitmap into an array of 128 by, I think it was 78 for total float values, put that into an array and feed the model. So the idea is to put, you have to generate the data and in the same way that you train the model. Otherwise, the model will not perform well. Not only perform well, that it will give errors because it's not the data that is expecting. I think, yes, this is I maybe go to the app, but the method that the function for run the inference in the Android app. So this app, because it's not for the assignment, I wanted to show also the option of running the model in a background. So you will see that it's running a task, but the app that I provided for the assignment is simpler. So you will see that there is no like background task. But I think because you will not work much on this app, I think at least that you know that it's possible to run the inference, run the model in the background of the app. So it's basically getting the bitmap from the draw view object, and then it's calling this classify asynchronous bitmap. And because it's using a task, it calling the on success and on failure listener. But yes, I may briefly show. You have the app, but then this is the function that I was mentioning, classify. Well, it first calls classify asynchronous, and then that call this is where you are doing the classification. And basically what it's doing, the timings is because we are using that background task, but in the assignment, it's just doing everything in the foreground. So what we're doing here is we are creating a byte buffer. We are basically creating an array, a byte buffer of the bitmap, because that's how we train the model. We didn't train the model like giving a bitmap, because bitmap is a concept for Android for representing pictures. So we have to create a byte array from the bitmap. And with that, we can just call the model. So to the first thing, we have to call initialize function, and it's yes. So much. Well, I think I will. I'm not sure in which. So let's go back to the slide, because I think in the last part is where I show how to include your model into your app. It's basically in the asset folder you create. Well, now that I'm here, I will just show it. So you would create app, new, your folder, and then create assets folder. When you click here in asset, it will create this folder, and then you will just put your model here. And some part of the code you have to I have the name of the model. I think I have it in here. So it has to match exactly the same name with also the format, TF Lite. And yes, you have the app, so you can follow like, for every different model is the same. You load the model, then you initialize the interpreter, and then the main difference between this and what you would be doing in the assignment is the name of the model and how you prepare the data so that it's in the format that you train the model for. The rest is the same because we are using the same kind of model. I think there is nothing more to.
Professor Lara.
Yes.
I think I'm missing a little bit when you go from the Jupyter Notebook to the Android Studio. I think I'm missing probably a step. I don't know if you're going to show that, but
yes, I am. Okay. You are going to do that in the second part, because in this part, I don't exactly. You don't get to download the model. No. So in the second part, you are going to download the model, and then you are going to get in your computer, is going to go to the download folder, this file, and then you would have to put that file in this folder, and then you have to call this as if it was a function. For example, yes. So let's quickly go through the code. So when the user finishes drawing, it will call this classify drawing, and this function will take the bitmap, and then we'll call this function from this class. And this class will initialize the interpreter for this model. And then you see that this classify the input is a bitmap. So you have to think of this as a function that you give an input, in this case, the bitmap that you have to convert to an array of numbers. And then the output is going to be because the output, you define like 10 different classes, is going to have for every class one probability. That's the output. Like, yes. But I think the way I put this, it's what is showing in the app is the number with the class with the highest probability. But it's going to give you for every class refers to the possible output, like would be the 0, 1, 2, up to 9, and the probability that for that input, it corresponds to that particular output class. So when you call, you have to do some initialization for the model, but yes. Here you load the model, you initialize the interpreter, then you specify the input shape. In this case, the width and height of the bitmap. For the case of the assignment for the accelerometer, I give all this data. And then where is the line where is actually running? Yeah, so I think here is where we are, and someone look chat, where you run the model. This is the input, and the input for our model is the bitmap that you convert to the byte buffer, because that's how we train the model for. And the result is the output from that model. That is going to be for every class the probability. The probability of for that input, what is the probability that being a 0, 1, 2, 3, up to 9. So the idea is that you can think of that as a function that you have to initialize and then call it with this command, and the input is, in this case, the buffer of the bitmap. For the assignment, the input is going to be an array of float values from the accelerometer. Do you have it? Well, you will actually download the model from part 2, and you will be able to integrate it in here. And all of this is provided. But for the assignment, the only thing is that the name of the model is different. And when you initialize the model, just initialize it for this name. Just consider that the input is different. Instead of being the buffer array with the float value from the bitmap, the input is, I don't want to say the number because it's part of the assignment, an array of certain length, let's say 200 values for saying some number, and with X, Y, and Z. So it would be like 3 by the length 200 in an array, and that would be the input. That's the difference with this. So the idea is that when you use a model that you place it on the asset, you have to understand what is the format that you have to put the input to be able to fit that model. Then the rest of the part is just standard format of initializing the model and getting the model from the asset file. That's the same for different models. given the specific input shape. That for the assignment would be 3 because it's X, Y, and Z, and then the length, how much data from each axis do you need? Yes. There are more questions, just ask. Well, I can look at the chat while we are like in breaks if you have questions, but while I'm talking, I don't have eyes to look both at the chat, so I prefer that you speak. So yes, we have 1 hour, so I think we have time because I was briefly looking at the chat that some people even finished the second part. I was saying that if some of you had good experience with deep learning, this might be like fairly easy because I give everything just like plugs on numbers. But for those of you who is new, this is maybe like not even easy, but too much information all of a sudden. But well, you were wondering that works more or less fine, but just by defining a new model would be the best solution for this. That's how we are going to build what is called convolutional neural network. I have a few slides to also give you a brief overview of what it is, because for the assignment, I also provide the model, but it's based on convolutional neural network. Opera. This is typo. Okay. So the convolution operation is, the idea is to get a filter of a certain size and slide that filter on the input and sum all the values, and that would be the output. So this is the input. You would place this on top of this size and multiply value by value, sum all of them, and that's the result. I think I have a better slide. It's very widely used for filters for image processing. And the idea is to spot like 2D patterns, but I think this is a better example. So first, in this example, we have like a 3x3 filter. So the idea is that you element-wise multiply the filter with the input. For this case, element-wise multiply, add the numbers, and the output would be this 3. Then you slide the window by 1, repeat, second number. Basically sliding the window over the input image, but it doesn't need to be an image, the input matrix, and repeat. And sometimes it's called stride. You may not want to slide like 1 by 1 position. You may want to slide in step of 2 or 3, depends. And it's also called the concept of padding. I didn't want to have a slide because I don't think it's important for here, but you may want to include some zeros on top to start from 1 row above. So you could add what is called padding, but that's the general idea. So what we are going to do to improve the previous model is build a convolutional neural network for digit recognition, and this type of networks are based on convolution. Instead of having those all fully connected neurons that all the inputs are connected to all the outputs and so on, we are building this network based on the convolution operation. So you would have our input, this 28 by 28, and we would have a different number of filters, 3 by 3. And then you can start to see that the output is not the same size as the input. So it's a way of not having, in the video, I think they mentioned how many ways and bias we have if we do like element, like all neurons are connected to all neurons in every layer. So if we use this convolution, we are reducing the size. That it depends on if you destroy it or on the padding, how much is this size, but you can see that the size is reduced. So Yes, there are, apart from the convolution, two other operations that we are going to do for this network that, so I think the concept is, I think it's more or less clear. So you take the input and then you do these 3x3 convolution filters. And then another operation this widely used, and in our model, I think it's 2x2. It doesn't correspond to the picture. I think this picture is from the assignment. So the idea is that you select part of the input. In this example, in this slide is 3x3, and you take the maximum number. So this would be like max pooling. There is also other type of pooling. The idea is that to reduce even further the size by selecting one number among a set. So we are taking every 3x3 and only get the maximum value. Yes. Then the other part is another convolution operation. Then other max pooling to even reduce further the size and maybe select some feature of interest. And one thing important is, maybe you're wondering how to design this filter in particular. So the short answer is, well, for image processing, there are like some well-known filters for example, for detecting edges, or for other features, there are some predefined and known filters that they have been studied. And also, if you have worked with this system a lot, you more or less know the filters. But for now, just I give the filter, so you don't have to worry about that. The last part is important, is flatten and then fully connected. So because we want to, the output, we want to get 10 output classes. We have 10 digits. For the assignment, we want 2. The yes or win and no yes or. So after all this operation, we need an array of 10 values. So for that, we have what is called the flatten, because the input in this case is not an array of, the input right now is this 24 by 24. So we want to, what is called flatten, we want to transform a multidimensional tensor. And this will give, in this case, 900 units. So after that, we have, I think this is the layers that we saw before, fully connected, connecting every single input to all the outputs. The same, and then the output is 10. The number of like Y900, or also like the particular selections, I didn't, this has been studied like quite a lot, the hand recognition. So this, like the person who first designed this, he didn't just, okay, this has to be this. No, they probably like tried and tuned the parameters, the hyperparameters, and they came with this solution. Yes, I think another thing that I didn't mention. So in part 2, you will download the model, you would place it in the assets folder, and then you would need to add this TensorFlow Lite interpreter. And you do not need this for the assignment, but for the example app, because you are running the inference on a background task, you need to, it's already in the code, but in case you want to run inference for a model in the background task. So after this, I think I will reassign the groups until 9, I think, or does anyone, you can like talk or speak in the chat, because I don't know how how far you got. So do you think, maybe you can write in the chat, do you prefer like 20 minutes if enough, or you prefer like 30 minutes, so that we have some time, because I only have like a few slides left. And
So do we submit part 1 and part 2, 3, 4 separately, or we submit everything in one file?
it doesn't matter.
Okay.
Yes. Yeah, I'm going to use the same groups that seem that they are safe. So did any, I don't know, not too familiar of interacting with like Zoom, how to ask things in the best way. So I'm not sure whether to give like, because I don't want to give maybe half an hour, or maybe most of you already finished, so maybe like too much, or, but okay, so I'm going to give half an hour, because after that, like 2 slides, and I will probably finish. And if you finish, just go back to the main room, because then I can see that if all of you are back, then it's too much time. So I'm going to give half an hour, or mostly half an hour. And if you finish, just don't stay there, come back to the main meeting, so that I can see like how finished, how far did you get. So I will, yes, I will open the same rooms. So, and only one member of the group need to submit, but include, I forgot to say, include the team members, please. I think I can find out later, but just it would be easier. And again, if you have questions, just click on the help button. And I will stop recording, pause. We'll start recording again. I think all the rooms are closed. So I just have maybe like 10 more minutes or 15 more minutes, and then we will just leave if you want to leave or have any question with the assignment or anything. And the last part, I wanted to briefly introduce the assignment. Usually I don't have time, but this time I will briefly introduce the assignment, and it's maybe show one way of saving the data of the accelerometer, so that you can extract the data from your app. And yes, and then I will have, if anyone has question about the assignment or the class activity, yes, can ask. So I will share the screen now. So yes, the assignment is, the idea is the same procedure that you have been doing for the digit recognition, but we are going to recognize some gesture. In this case, this wing gesture, and to match this behavior, you should hold your phone horizontal and then do the movement like this, and it would classify 2 gestures, like wing or unrecognized. So I provide the same as before, the Jupyter Notebook file, and you can run it as you want. You can use the Colab or other platform. And I will open this, because this is, this has like quite some more code. Instead of having all the code in here with so many comments, I have all the material in GitHub. So what I did is, if you run the first cell, you can download the material from GitHub, and you don't need to use Colab anymore. You can just run these 2 files in other platform we do using Colab, and it's the same. But I wanted to make it easy for like people with like first approach. I think Colab works pretty good. And you can also work like shared document. I don't think like Colab for like real-time simultaneously sharing document, I don't have very good experience, but sometimes there are some conflict of people accessing the same file. So it will download this folder assignment 4, and this is what you will need for the assignment. So you can just, you don't need to use Colab, just can download this and take the file from here. And it has two parts where it prepares the data to train the model and then the model training. It has some comments inside and then some parameters so that you can follow a little bit better the results. So I provide all the code. You just need to fill some missing parameters. I think the first part is, I think it's going to be fairly easy. And then the only thing that I ask that I think is kind of explained here, that when you go to the train model, to the train file, there is one part where you download the file and the TF-Lite file. To make sure that each of you have used your own file, I ask you to change the file name with your name and last name so that each of you have a different model. You can always like change the name, yes, of course, but I think at least so that you learn how to, I think the main goal is so that you see in the code where the model is safe, and it makes you also look a bit more of the model generation and how to convert the model into TensorFlow. And then you have to place the model in the app, as I said. That's the first part. I think it's pretty easy. And the second part is kind of the key. So it's also like not much code, but I think it's explained here. So the model is trained with data sample from the accelerometer with 25 Hertz for X, Y, and Z. So you need to, with that, is about 128 values. And these two numbers, this will give you the key of how often you need to, when you register the listener for the accelerometer, how often do you want to read the values? You want to read the value with this frequency, but in Android, when you register the listener, you don't specify the frequency, but the sample time. And then you need to, the app is given, you just need to finish this on sensor change function and this make prediction. You have to read the data with the accelerometer with a certain frequency and feed that data to the model. I will show a little bit the app now. And you also, apart from these two functions, the other thing that you need to specify these two parameters, and here like place the name of your model. So quickly, well, I don't want to, yes, I will explain it like using this one. So apart from these two functions that I don't want to give more detail because that's kind of the key of the assignment. The only difference that we are going to see with this digit classifier that in the assignment is called gesture classifier is the input shape 1 would be 3 because we have like X, Y, and Z by 128 values. And the rest in this, it's fairly similar, but the app is provided except for these two functions that I don't want to give more detail because that's the key of the assignment. And before the last part, it would be ideal if we have more time or at least give you 2 weeks to because for the win gesture, I provide the data. So you have a file with the data with X, Y, and Z from like set. You will see that the accuracy is not like super good because maybe it's not enough data set, but I don't care that much about how well the app is going to perform, but I'm going to look at the code if you actually implement it in the correct way. It would be ideal to have you to record a new gesture and retrain the data with a new gesture that you record. You define that gesture. I'm going to do a circle. So I want to train the model so that my app is also able to recognize this gesture, this new gesture when I move the phone. It would be ideal if we could do that, but for time constraint, I think I could give you 2 weeks, but I think maybe I could have, but I wanted to also cover other topics. So what I asked is it would be ideal if you could like implement it, but I asked you to specify in a document the steps that you would take to, if you wanted your app to recognize a new user. The main limitation for not implementing this is like having the data, because if you want to record that yourself, you will have to have, I don't know, like thousands of instance of that data set. So define a window of 5 seconds and record the gestures and save it in a file. So you have to repeat that thousands of times so that you have like a fairly good data set and then train your model. So I think it would take quite some time so that you have to, for you to generate that data set. And for that, because of that, I asked you to just write a document of the steps that be a specific, the more detail that you give, the better. And you don't need to implement this because the main limitation is that it will take you some time to generate the data set. Even though we are not going to generate the data set, but I think I mentioned at the end of the document that if you want to extract, because okay, you are using the font to generate the data set. So you want to define, you want to have one recording would be like, I don't know, 200 values. That's one data value, then continue. So you want to extract that data from the accelerometer, from the app, so that you can use it to train your model. So there are different ways, and I would mention like the most intuitive one that you could use. I'm trying to fix it. So one, it's not recommend, well, not, you could just like log the values here and then basically copy all and paste in a text file. You can send the data in a specific format in a mail. Well, obviously you would have an SD card and save that in an SD card, but thinking in terms of like the phones that you have, we don't have SD cards. So if you wanted to not just generate a data set, but maybe just extract some piece of data from the accelerometer, because you don't have SD cards for the, or any external memory from the phone, assuming that you don't have external storage, would be like the logcat, sending by mail, or I provided, I think I provided this in the second lecture, but we didn't really talk about it much. You can save the data in the internal memory of the app, and by internal means that not other app can access it, but you can actually access that data from Android Studio. If you open here the device explorer, will open this, and you can use it for running the emulator or the phone. So I have this main activity that I create this file name called myfile.txt, and I have two functions. One is to write on the file and one is to read. So imagine that you want to write this float value with this specific syntax, x and the value. So you would use this, open the file with this name that you give and mode private, and then you have to convert it to byte array. So I will show you how to see that data in the file in case. You can also access this file or this like a structure if you look in your Android phone, but with emulator it's also possible. It's running the other app. So it will go in, no, it's not still running. I think I have it. Yes, well, basically you just like look for the file in here. I think it's finished. Yes, go. No. Where did it go? What? Yes. So yes. You go through data app and try to find your app in here. File. I remember I'm not, every time I try to do something online, I did this today. So anyway, try to find this file in here. I did this like this afternoon, so it's there. And that's how I typically, like if I don't have external storage, take the data out. Because if you use the logcat, it will create some, well, you can set the properties so that you don't see all the specific directories on the logcat, but still this is preferred. I think that's all I wanted to say about the assignment. But so next week will be just back to what next week will we introduce Arduino and how to interact Arduino with Android for 1 lecture and a half, and then we'll just the last 2 lectures just back on Android. So any question in general from today or past lectures? I feel that I talk a lot, but you can use the chat also if you have questions, if you prefer, instead of talking. I can't understand, like it can be awkward to talk when everything is in silence, but.
Hey, Professor.
Yes.
When you finish the class, are you able to like bring us to the group if we still not finished the practice?
Like, yes, to go back to the groups?
Yeah, I mean, if after you finish the class, can you break us up to the group
Yes.
we had, so we can talk about more how to like
yes.
do that.
Okay. I checked because it's the first time that I try this. I still maintain the same groups, so I can open the rooms and yes. The class is finished, so I'm now just seeing anyone has question, but I can keep the rooms open until 10. So.
Oh, okay. Thanks.
Any questions or? I hope that people with no background in deep learning at least could more or less follow the class and understand how to integrate that with Android. So the assignment, because I want you to focus on the Android part, that's why I gave you all the code of the model. So just like.
So does this assignment for due next week?
Yes.
Or we have 2 weeks?
No, next week.
Okay,
Friday.
next week.
Yes, because the last part, you don't need to train the model for a new gesture. I just want you to think if you had to, how you would do it, and like be as specific as you can, like writing down, I would do this, this, and this. As specific, the more it's going to be like maybe better for the grade and maybe also better for you, because you will realize you had to do it how you would. For example, how you would record the data. You could say, okay, I would record the data with the phone, I will save the data this way, then I would, yes. But you don't need to be, well, the more specific, the best, and that's it. But you don't need to implement that. I think the assignment is already open and it's Friday, 10 p.m. next week. Yeah. More questions? You can use the chat, I insist, but I understand that it's kind of awkward just talking with everything in silence. And what last thing before I end? Well, I'm going to open the rooms in case some group wants to go back to work. I already have the material for the last 2 weeks, but if someone needs, if you are already thinking about your final project and you see that there is a topic that we are not going to cover that you will need it for your final project, you can just email me and I may just adjust a little bit the content. Because Android is like huge, so we can't cover everything. I try to select the main topics, but if there is a topic that we are not going to cover and you think that you want to know it for your final project, just you can email me and I can include that in one of the last 2 lectures that we talk about Android. Okay, so if no more question, I will stay here. But so if you have questions, you can in the chat or speak, and I will keep the room open until I think the official time of the lecture is 9:40 or 9:50, I think. So at least 9:50, 10. If not, I think good luck with. Don't forget the assignment is due tomorrow. I open a late version in case someone missed the deadline, so that for now I want to avoid having people email me the assignment, so that's why I open the late version. That is, it doesn't close. But okay, so have a good weekend and good luck with the assignment. This one is, I think it will take you less time to complete.
Thank you. Have a good night.